Hello everyone. Today we are doing combination of resistors. See, there are two possible way of connecting resistors. Okay, that is series and parallel. We can connect resistors in series or in parallel. What is meaning of series? Series means when same amount of current is flowing in each resistor. Say there are 3-4 resistors connected together and same amount of current is flowing in each. Then we say combination is series. And when current split, after coming to one point, if current divide and go, then it is called as parallel combination. Okay, so there are two types of combination, series and parallel. In series, current remains the same, and in parallel, current divides. Okay, few more point to note. In series, current is constant. In parallel, current divides. In series, voltage will divide, like across each resistor voltage will divide. Okay, total voltage of circuit you will get by adding voltage in each resistor, voltage as in potential difference. In parallel, since they all have common junction, so across the junction potential difference will be same. So in parallel voltage is constant and in series current is constant. Okay, in series total resistance of the circuit, total resistance, I can say total resistance, I can say resultant resistance, I can say equivalent resistance, I can say effective resistance. So these are the four different ways of saying same thing. Okay, total, equivalent, resultant or effective, they all mean the same only, means total resistance of the circuit. In series we can find that by adding resistors of each resistance of each circuit, just add them. And in parallel you have to add their reciprocal. Okay, so when you add their reciprocal you will get total resistance of the circuit. Now main point, please understand this point properly, because this is whole concept actually. See, total resistance in series is always greater than the greatest value of resistance. Total resistor is always greater than the greatest value. Suppose I have three resistors of 2 ohm, 4 ohm and 6 ohm. So here net resistance, total resistance will always be more than 6 ohm. Whereas in parallel it will be less than 2 ohms, because here least value is what? 2 ohms. So total resistance in parallel is always less than the least value of resistance. Remember this. Okay, fine. So let us see some numericals. There are 7 numericals which I will do, and hope this 7 numerical will clear all your concept of series and parallel combination. Let us start with the simplest one. See here, I have to find resistance between A to B, and here there is no other path, so directly we can say they are in series. So Rs is equal to 6 plus 3, that is 9 ohm. Okay, directly, simplest one. In second sum, here there are two resistors connected in parallel. How can I say they are in parallel? Because see, from A till here there is no path, but after coming to this there is junction. Some current will go here and some current will go here. Means current is splitting, that means they both are in parallel. So to find equivalent, I will use formula of parallel, that is 1 upon Rp is equal to 1 upon 6 plus 1 upon 3. By simple maths, on solving this you will get Rp as 2 ohm. Okay, you can solve this easily by LCM method. So Rp will come 2 ohms. Okay, now see this combination. Okay, here 6 and 4 ohm, they are appearing parallel. Okay, it is as if they are parallel, but actually if you see, I am saying resistance between A and B. So I'll start from A. So suppose X amount of current is going in 6, same current will come in 4 also. Though they are looking parallel, but current is not splitting. That means they are in series. So remember, in this kind of combination, you don't have to look at the figure. You have to see whether current is splitting or not. Here current is not splitting, that means they are in series only. So total resistance Rs will be 6 plus 4, that is 10 ohm. Very easy. Okay, now come to sum number 4, one of the confusing question. Okay, So see here, what is given? There are two resistors, 3 ohm and 5 ohm. Okay, and across 5 ohm, you will see there is one wire without any resistance. Okay, so most of the time what we will do, we will ignore this wire. Since there is no resistance, we will say this wire is just for time pass. Okay, but there is very deep concept over here. See, understand this point. Total resistance in parallel is always less than the least value, right? Now here, this wire is showing zero resistance. Resistance of this wire is zero, and it is connected across 5 ohm in parallel. Okay, so now net resistance will be less than zero, means this combination is giving you zero resistance. Such method is called as short circuit, short circuiting the resistance. Okay, so whenever one zero resistance wire is connected across any resistor, zero resistance is not possible, that is superconductor. But suppose if one plain wire is connected across any resistor, then that resistance will become zero. This method is called as short circuiting the circuit. Okay, so now here only one resistance is there. Okay, so total resistance will be 3 ohm, that's it. Okay, so this value will become zero, only 3 ohm is there. Okay, fine. Now come to little complex one. See here, in this diagram, you have to find resistance between A and B. Okay, so in such combinations, always put yourself in the scene. Okay, assume that you are standing at point A and you want to go to point B. Okay, so there are how many ways? Most of the people will say only one, will take shortcut. Okay, but you can take shortcut, but whenever you have two paths, both paths you have to consider. In circuit you have to consider both the path. So I can go directly like this from A to B, or I can go through long cut. Okay, means I have two ways of going from A to B, and whenever I have more than one path, these paths are in parallel. Remember this. So whenever we have choices are always in parallel. Okay, so here I will use formula of parallel. 1 upon Rp is equal to, in shortcut I have only one resistance, and in long cut I will encounter three resistances. Okay, so that is 1 upon Rp is equal to 1 upon 2 plus 1 upon 6. On solving this, you will get Rp is equal to 1.5 ohm. By very simple maths, when you will solve this, answer will come 1.5 ohm. Okay, now let's see sixth sum. Over here, question is calculate total resistance between A and B. Okay, now from A till this point, there is no other path. Similarly, from this point to point B, there is no other path. Okay, but what about these 2 points? Here there are paths, many paths. So in such case, just give name to this junction. Junction X, junction Y. Okay, now imagine you are standing at point A. You are going toward point B. In between, till here, from A to X, there is no option. You have to go. Say this is your home, this is your school. So from here till here, you have to go. There is no other option. But from X to Y, there are different paths. Okay, if you are a sincere child, you will go through shortcut method directly. But you can go through long cut to see your friends. Okay, so you can go by this path, you can go directly, or you can go by this path. So whenever, as I said, whenever you have different paths, these paths are in parallel. Okay, so first I will solve between X and Y. So here I have choices. So these choices are in parallel. I will use formula of parallel. 1 upon Rp is equal to 1 upon, in this path I will encounter three resistors. Okay, then shortcut path only one, and again here there are three resistors. So 1 upon Rp will be 1 upon 3 plus 1 upon 2 plus 1 upon 6. So when you will solve this, I will get Rp as 1 ohm. Okay, so this total will give me 1 ohm. Okay, now this 1 ohm, now this total resistance is 1 ohm, which is coming in series of 2 and this 2. So finally, total resistance I will find by adding them. 1 plus this 2 ohm. So 2 plus 1 plus 2, that is 5 ohm. So here total resistance, equivalent resistance is 5 ohm. Okay. Now come to last sum. Very complex one. Okay. Mostly this kind of sum will not come in board. Okay. Just for your concept, I will try to explain this, how to crack this kind of complex sum. Okay. Here I want to find resistance between A and B. Fine. So if I start from here, see, your junction is there, some current will go here, some current will go here. After coming to this point, again some current will go there, some current will come here. So this is very complex circuit. Okay, so I cannot start from complex end. I will start from simplest end. So this end is simplest end. Why I am saying this end as simplest end? Because see, whatever current is coming over here in this 2 ohm, same will go in 3 also, same will come in 5 also, because here after this there is no junction. So what to do? Solve this first. These three are in series. Okay, so first thing will be finding RS1. Okay, so I will find this. This is 2 plus 3 plus 5, that is 2 plus 3 plus 5, that is 10 ohm. Okay, now RS1 that you got, RS1 that is coming in parallel with this 10 ohm because there is common junction. Okay, so I will find RP1. So 1 upon RP1 will be 1 upon 10 plus 1 upon 10. On solving, you will get RP1 is 5 ohm. Okay, so RP1 you got, means now this path also you got. Till here you solved. Now this RP which you got 5, that is coming in series with 4 and 1. Okay, because now this part is solved. Now this is acting like one resistor having value 5 ohm. So 4 plus 5 plus 1. So RS2 will be 4 ohm plus 5 ohm, which we got as RP plus 1 ohm, that is 10 ohm. So now this total value came 10. Okay, now that 10 is in parallel with this 10. So find RP2. So 1 upon RP2 will be 1 upon 10 plus 1 upon 10. Again RP will come 5 ohm. Okay, by simple maths you will get RP 5 ohm. Now last thing, now till here I got 5. Okay, now that 5 is in series with 6 and 4. So final answer RS3 will be 6 ohm plus 5 ohm, that you got as RP, plus 4 ohm, that is 15 ohm. So total resistance of this combination is 15 ohm. Hope you understood this concept of series and parallel. If you have any doubt, you can WhatsApp me or call.